Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 24, True and False Number Sentences. So we're starting off with a classwork opening exercise, and it says to state whether each number sentence is true or false. If the number sentence is false, explain why it is false. So pause the video, do these 5, and see if you get the right answer. Okay, here we go. 4 plus 5 is 9. 9 is greater than 9. That is false. And I'm not going to take the time to write why, I'll just say why. 9 is not greater than 9. That's why that is false. 4 plus 5 is not greater than 9. Okay. Second one, B. 3 times 6 is 18. 18 equals 18. That is true. C. 32 is greater than 64 divided by 4. There's 2 ways I can solve this problem. I can either divide 64 by 4, or I can multiply both sides by 4. I'm going to multiply both sides by 4. And this will leave me 64 on the right. And 4 times 2 is 8. 4 times 3 is 12. 128 is greater than 64. That is definitely true. D. 78 minus 15 is less than 68. 78 minus 15 is 63. 63 is less than 68. That is true. And E, 22 is greater than or equal to 11 plus 12. 11 plus 12 is 23. So if I bring down 22 and the inequality, this is now saying 22 is greater than or equal to 23. That is definitely false because 23 is not less than 22. 22 is not greater than 23. That is false. Okay, so example 1. Write a true-false statement if the number substituted for G results in a true or false number sentence. Okay, so we have substitute G with these values. We're given an equation. We're given an equation. We're given an inequality all the way across. And it says write true or false if the number substituted is true or false in the sentence. So I'm going to substitute in 8 for G. So that would be 4 times 8 equals 32. 4 times 8 is 32. 32 equals 32. That is true. They aren't giving us a lot of room to do this. Okay, so I'm going to go vertically, and I'm just going to plug in different values for G. So then if I do 4 times 4 equals 32, that's 16 equals 32. That is false. 4 times 2 equals 32. I better write a little smaller. Put that back. So we have 4 times 2 equals 32. 8 equals 32. That is definitely false. 4 times 0 equals 32. 0 equals 32. False again. And 4 times 10 equals 32. 40 equals 32. False. Okay, now we're going to plug in 8 for here, so that's going to be 8 equals 8. True. 4 equals 8. False. 2 equals 8. False. So obviously with an equal sign, you're only going to get one answer that is true, and that is the number that makes it true, and that is all. So 0 does not equal 8. That's false. And 10 does not equal 8. That is also false. So here's the only true statement. Okay, so on to the next one. 3 times 8 greater than or equal to 30. 24 greater than or equal to 30. False. 4 times 3 times 4 greater than or equal to 30. 12 greater than or equal to 30. False. 2 3 times 2 greater than or equal to 30. That would be 6 greater than or equal to 30. That is also false. 3 times 0 greater than or equal to 30. 0 greater than or equal to 30. False. Okay, plug in 10. 3 times 10 greater than or equal to 30. 30 greater than or equal to 30. That is true. There's my only true statement. Okay. Alright, so now I'm just going to continue doing this, and now I'm plugging 8 in for G. 8 greater than or equal to 10. False. 4 greater than or equal to 10. False. 2 greater than or equal to 10. False. 0 greater than or equal to 10. False. 10 greater than or equal to 10. That is true. Now I'm plugging 8 in for G to this one, so it would be 8 over 2 greater than 2, or 4 greater than 2. Not equal, just greater than. But that is true. Plug in 4. 4 divided by 2 is greater than 2. 4 divided by 2 is 2. 2 is not greater than 2, so that is false. Now I plug in 2. 2 over 2 greater than 2. Well, 2 over 2 is 1. 1 is not greater than 2, so that is false. 0 divided by 2 is greater than 2. 0 greater than 2 is false. And if I plug in 10 for G, I get 10 halves is greater than 2, which reduces to 5 is greater than 2. That is true. So this one had 2 true statements. Okay. 8 greater than 4. True. 4 greater than 4. False. 2 greater than 4. False. 0 greater than 4. False. 10 greater than 4. True. So this one had 2 true statements. "30 is greater than or equal to 38 minus G. 30 greater than or equal to 38 minus 8. 30 greater than or equal to 30. That is true. 30 greater than or equal to 38 minus 4. 30 greater than or equal to 34. False. 30 greater than or equal to 38 minus 2. 30 greater than or equal to 36. That is false. 30 greater than or equal to 38 minus 0. 30 greater than or equal to 38 is false. 30 greater than or equal to 38 minus 10. 30 greater than or equal to 28. True. So in this one, this is true, and this one is true. 2 solutions. And now when I plug in 8, 8 greater than or equal to 8, true. 4 greater than or equal to 8, false. 2 greater than or equal to 8, false. 0 greater than or equal to 8 is false. And 10 greater than or equal to 8 is true. So that one had 2 true statements. Okay. Example 2, it says to state whether the following equations or inequalities will be true and when they will be false. When will they be true and when will they be false? So all we have to do is solve for the variable here. And when we're solving equations, remember the acronym PEMDAS. Please excuse my dear Aunt Sally. And now we have changed that to a G for grouping, not parentheses, so it's GEMDAS or GEMDAS. And that's to simplify expressions. But if we have an equation, we're going to work in the opposite direction. So we're going to do what I say is SADMAP or SADMAG. And we go in this order. We subtract and add first, divide, multiply next, exponent, and then lastly parentheses. And we're doing inverse operations to move across an equal sign. So I see addition, and the inverse of addition is subtraction. So I'm going to subtract 15 from both sides. And when I do that, I get the 15s to cancel, and I get the variable all by itself, and that's what I want to know. I want to know what makes R, I want to know what R is that makes this true. So 25 minus 15 is 10. So state when the following equations or inequalities will be true and when they will be false. So it's true when R equals 10, false when R does not equal 10. So any other number, 9, 11, 10.1, there is no number other than 10 that will make this equation true. Okay, inequality, 6 minus D greater than 0. 6 is a negative, is a positive number. 6 is positive 6, and we're subtracting D, and that's greater than 0. So I see that it's addition, it's a positive 6, so I need to subtract it to get rid of it. So when I subtract, this goes away, and I get negative D greater than negative 6. I don't want my variable to be negative, and do not forget to bring down that minus sign in front of the D. And minus and negative mean the same thing. Minus just means plus a negative. So, okay? So I don't want this to be negative, so I'm going to multiply by negative 1. A negative times a negative is positive. When I multiply a negative and I have an inequality, it changes direction. And a negative times a negative is positive. So it is true when D is less than 6, false when D is greater than or equal to 6. Okay? Or C, 1/2 F equals 15. We're multiplying F by a half. So if we're multiplying, the inverse is division. But I don't want to divide a fraction by a fraction. So, because we can't divide by fractions. We have a rule in math that says to multiply by the inverse or the reciprocal. So I'm going to multiply both sides by 2, which is the same as 2 over 1. So I'm going to multiply both sides by 2. And the 2 times a half give me 1/2, and 15 times 2 is 30. So this is true when F equals 30 and false when F does not equal 30. All other numbers greater than or less than 30 will make that false. Okay, D. Again, we have division. Push this up a little too far. I'll leave that here. So we have y divided by 3. That is division. The inverse of division is multiplication. So I am going to multiply both sides by 3. And those cancel. And I get y is less than 10 times 3, which is 30. So this is true when y is less than 30. And false when y is greater than or equal to 30. Okay, E, that is 7 times G. Multiplication's inverse is division, so I will divide by 7, divide by 7. 7's cancel, and G is greater than or equal to 42 divided by 7. So this is true when G is greater than or equal to 6, false when G is less than 6. And finally, the last one, I have a negative 8. That's the same as plus or minus, so that's subtraction. And the inverse of subtraction is addition. So I'm going to add 8 to both sides. When I add 8 to negative 8, I get 0, so a plus 0 is simply a, less than or equal to 15 plus 8, which is 23. So this is true when a is less than or equal to 23, but false when a is greater than 23. Okay, now this is an exercise. It says complete the following problems in pairs. State when the following equations and inequalities will be true and when they will be false. Now it's your turn to do what I just explained. Pause the video, do number 1 through 7, and then come back and check your solutions. Okay, so here we go. Starting with this one. That's multiplication, so I'm going to divide. 15 divided by 15 is 1. 1 times c is c. 45 divided by 15 is 3. So this is true when c is greater than 3. And I'm just going to shorten this up now. False when c is less than or equal to 3. So I'm not going to take my time to write all this out, but you still should do that. I'm just saving time in the video. All right, number 2. 25 equals d minus 10. Add 10. The opposite, the inverse of minus is plus. So I get 35 equals d. So it's true when 35 equals d, and false when 35 does not equal d, or d does not equal 35. All right. 3. Multiplication's inverse is division, so we're dividing. 56 divided by 2 is 28. It's greater than or equal to e. That's when it's true. E is, I could rewrite this like this. I should have, no, that's equals. I could still write this up here too. If you want, you should get in the habit of putting the variable on the left. So when I do that with inequalities, make sure you, the sign, this still opens towards the 28, so this gets reversed. So e is less than or equal to 28 makes it true. What makes that false is when e is greater than 28. Don't use an equal sign twice. It can't be true and false when they're equal. And this is division, so I'm going to do the inverse of division, which is multiplication. 5's cancel. H is greater than or equal to 60. That's when it's true. And it is false. H is less than 60. This is addition, inverse is subtraction. 45 minus 29 is 16. And then these cancel, and I get H. I'll rewrite that so that the variable's first. So it is true when H is less than 16, and false when H is greater than or equal to 16. All right. Last one, that's multiplication. The inverse of multiplication is division, so I divide both sides by 4. A less than or equal to 16 divided by 4, which is 4. So it is true when a is less than or equal to 4. It is false when a is greater than 4. 7, this is multiplication, inverse is division. X equals 8. That's when it is true. It is false when x does not equal 8. So in other words, I could also say it this way, and I think I should at least one time. X is not equal to 8 could mean x is greater than 8 or x is less than 8. Okay. All right. So now it says identify all equality and inequality signs that can be placed into the blank to make a true numbered sentence. So I'm going to solve this underneath. I'm going to simplify this. 15 plus 9 is 24, and the symbol that would make that true is an equal sign. 8 times 7 is 56. So I could put is greater than, or I could put is greater than or equal to. Either one would work. Okay, so I will put both. Those are the two possible answers. greater than or equal to, or just simply greater. Okay, number 10. 15 divided by 2 is 7.5, or 7.5. So I am going to put less than or less than or equal to. Okay. This one here, 17 times 2 is 34, so that's just an equal sign. Or is it? No, I'm thinking about this now. It could be equal. It could be greater than or equal to. It could be less than or equal to. Any one of those three. Since there's an equal sign in all of them, it is true. So if I go back to 24, that could also be greater than or equal to 24. And that could also be less than or equal to. Okay, so it doesn't just have to be an equal sign if they are equal. So now I have 24.5 minus 6. 24.5 minus 6 is 18.5. So that is going to be less. Or I could have less than or equal to make it true. Okay. That is the end of lesson 24. Go do your problem set.